All right, thank you everybody for being here. Welcome. And today we're going to talk about GraphQL and Kotlin. So my name is Benoit, and I work at Apollo.
Hello, my name is Martin, and I work with Benoit at Apollo as well.
And maybe let's start with a quick refresher about what Apollo Kotlin actually is. So it's a type-safe and caching GraphQL client library for Kotlin and Java projects. And the way it works is that it generates code. So it will take your queries written in the GraphQL syntax and language, and with the help of the schema, it will generate models that you can use in your project, and some parsers that are able to instantiate these models and fill them with data coming from the Json payload from your server. And one benefit that you have when you generate code is that it's all type safe. So you can be sure that, first of all, there won't be any kind of runtime introspection or like reflection or anything like that. And also, like all the fields in the models, they will be of the correct type according to the schema. And that includes nullability. And you also get nice things like code completion, navigation, documentation in the IDE. It's open source. It's on GitHub, and it's on version 3. And this is a major version for the project. And in fact, you may have known the library with a different name, because it used to be called Apollo Android. But with this version, it's not really just for Android anymore. It's really for any Kotlin project, and that's why we wanted to reflect this with the name.
Including iOS.
Yeah, exactly. This, as I said, it's a major version, and that's what we're going to talk about this version, and we'll do this in three big blocks. First, like the big changes, like big refactoring and big features, and what we focused on this version. Then smaller things and more like new smaller features, but also like quality of life improvements. And then we look at what's on the horizon for the next for the future. Also, yeah, I forgot to mention, since there's not too many people in the room, so don't hesitate. I think you can ask questions and interrupt us. Don't hesitate. So let's start with the big things. And the first one is Kotlin. So this is what you would see if you go to the GitHub page. It's fully written in Kotlin, even if it says here 98%, it's actually 100%. If you would look at this for version 2, there were still some code written in Java. All of this has been rewritten, and this allows us to benefit from the multi-platform capabilities of Kotlin from the ground up in the whole library. Let's look at how to use it. So in version 2, there were really two runtimes that you had to choose from. You had the JVM runtime, which was callbacks based, but you could add on top of this coroutines, some coroutines extensions for Kotlin, or you could use, if you needed multi-platform, use a specific runtime for that. But the problem with that is that it was not full featured. So you had to choose between all the features, including the cache and the multi-platform capabilities. While in version 3, all of this has been unified with one runtime, so it's simplified, and you have this runtime which is multi-platform and has all the features. If we look at the API, so we are firmly in coroutine and suspend world here. So here we show how to do a query. So if you don't know, if you're not too familiar with GraphQL, know that just a query is equivalent of a get in REST. And the thing to see here is that the execute method here is suspend. Same thing with mutations. So mutation is equivalent of a post in REST. So you would use that to create or modify an object on the backend. Same thing, execute here is suspend. If you would do a subscription, you would get a flow because you can get several results. And here again, the same principle. If you want to observe your cache, you would call watch, which also returns a flow. A bit more about multi-platform. So here on the left, we list a few libraries that are used under the hood. For networking, for persistence, we use SQLite, which is already a multi-platform library, so that works well with us. And here we mention the new memory model. So this kind of a recent development on multi-platform for the native targets, and Apollo Kotlin is compatible with that. And on the right, we show, like, I hope you can see well. Yeah.
I think it's big enough.
Yeah. So you see all the features that are supported depending on the platform. So you can see that Android and Apple and JVM are full featured. JavaScript is almost full featured too, with the exception of the SQL backend for the cache. So no persistence on JavaScript for now. And then yeah, you have Linux and Windows. Windows doesn't even appear here, but they're possible targets. They lags a bit behind, but this is something we could work on. In fact, if you need this new project, if it's something that you're interested in, don't hesitate to ping us, and we could prioritize this. So that was all for multi-platform. But another big thing is code generation.
My turn?
Yes, your turn.
Thank you. So yeah, Codegen. Codegen is a big value proposition of Apollo Kotlin. So Apollo Kotlin, as Benoit said, takes GraphQL queries on one hand and generate a bunch of Kotlin models from that. If you were to take a look at version 2, this is what you would see. So if you're not super familiar with GraphQL, bear with me for a few minutes. You have here on the left typical GraphQL query. It uses a little bit of everything. So you have a field called name. The thing below with ... on Droid is called an inline fragment, and it allows you to get some fields on a specific type. And just below that, you have human details, which is a name fragment. So you have really the three kinds of selections that you can see in a typical GraphQL query. The way you would use that is by using stuff like on the right. So this is all using Codegen, this is all using models, this is all Kotlin, so it's null safe. It's mapped really well with GraphQL. And in version 2, you would do something like this. So you would access inline fragment with stuff like as Droid. So you take your hero character, you cast it as a droid. I mean, not cast actually, and we will come back to that later. But you use something, nested field called as Droid, and then you can access the primary function. Same thing with name fragments, you would call .fragment.humandetails.8. And this is working well, except it's a bit weird, right? Because if you take a look at your JSON response that you get from your backend, there is nothing like Android or like human details or fragments. What you get is really two different JSON depending if you get a droid like C3PO or a human like Princess Leia, and there's no extra nested fields in there. So one of the goals we wanted with version 3, and this is something that we've had a lot of feedback in version 2, is why can't we just use the Kotlin models like we access the JSON? Like if you do this in JavaScript, it's really easy. You tap dot and you access the property. And what's more, like Kotlin has these nice features called sealed interfaces that allows you to use a when statement, like displayed on the right here. So you would just like have the different cases of your JSON, like the different possible responses, and you would just access the fields like you would do in your JSON. So turns out it's possible. Like I don't want to go into too much of the details, like there's a lot of code on that slide. Keep in mind that it's working because we use interfaces for fragments. So everywhere you had a nested dot as droid fragment or something like this, now you have an interface and you can cast between the different objects. So we were happy about it. We released it. We released a preview of it. And just a few days later, we were hit by this nice issue, exponential blow up in Codegen size. So we had this user, like this early user, write a 100 lines query. So 100 is a fairly, like, it's a standard query. It's nothing out of the ordinary, but like, it should work, right? And when it used that query, he made it possible to generate, I think, something like more than K lines of Kotlin. And this, in turn, it took like ages to compile, and it broke some of the limits of the JVM. I don't have the exact details, but I think something like number of bytes in the method. And here it even broke the number of the DEX format, which is the default format for the JVM on Android. So we were not happy about it. If we want to dive a little bit into this, I'll take a simple example, still using the Star Wars schema because I love Star Wars, not as much as Benoit, but I do. I'm going to get the ancestors of Luke Skywalker. And for this, I'm going to use fragments. So fragments, if you remember, it's a way to reuse properties that you have on an object. So I define a fragment ancestors on character, and I use it from my query, which is get hero ancestors. If I do this at level 1, I have 2 ancestors for Luke Skywalker. So far, so good. I know them. Even if I'm not a hardcore fan, I know that Luke has 2 parents, Padme and Anakin. I can do this one step further and use 2 fragments. So for each parent, I'm going to use a second fragment called ancestors2. And this gets me the grandparents. And I think there are 4 of them. I think. I can do this one step further. I get the great-grandparents. I have 8 of them. One step further, like 4, I can do the math. So it's 16. And at level 6, you get 64. So I think at this point, you see where I'm going. You have like the very definition of an exponential function. And the thing to remember is that because we generate the models based on the response and not anymore based on the like GraphQL, the bigger your response is, the bigger your Codegen is. So we had to backtrack a little bit and introduce operation-based Codegen again, which is something that's a bit more similar to V2, except it's a bit less verbose, so you can just keep the dot fragment stuff. And this will map 1-1 with your GraphQL. So remember, like the previous stuff, we called it response-based. It mapped 1-1 with the JSON. This maps with the GraphQL. Looks like this. Don't want to go into too much code. If I want to sum up, like you now have several options in Apollo Kotlin 3. You have the default one, which is based on your GraphQL operation. It's easy to understand because it's really like you write your queries, you use them in your code. But it's a bit more verbose. It cannot stream JSON, and I don't want to spoil your version, your section, Benoit, but it has a bit of performance impact, and it cannot handle all the polymorphism that you would have in a typical GraphQL query. GraphQL is a very expressive language. So you can express like very powerful queries, very large query in a very small subset of words. And with response-based Codegen, you can have this, but you're exposed to more generated code. So as always, it depends. The recommendation right now is to start with operation-based because it's easy. And once you're comfortable with it, and if you do not have too many like nested fragments, switch to response-based to have all the power and like all the performance of response-based Codegen. The king of performance, I will leave you the mic back, Benoit, to talk more about it.
Yes, performance is another area of improvement on of version 3. And let's start with JSON parsing. So on version 2, the way JSON parsing worked is that it was in two steps. First, we would load all the JSON payloads, we would transform them into maps, and then we would use these maps to fill the generated models. In version 3, we removed the intermediary step with the maps. And the way it works now is that the filling of the models is done on the fly while we are parsing the JSON. And so this is good for performance for two reasons. First, for memory usage, because you no longer need to store the whole payload in memory. So your garbage collector will be happy there. And it's also good for like responsiveness, because when we do that, basically you know that when you receive the last byte of your payload, your models are already there. They can be used immediately. So no need to first read everything and then do some more processing. And that's what we mean by parsing is mostly free here. However, there's a caveat because it's not 100% true. There's still some cases where we still need this intermediary step. That's when using operation-based Codegen, and some fields are merged in the response. However, this is strictly done as necessary, and also it's completely transparent to you, so it's just something we wanted to mention, but you don't need to worry about this too much. Another area of performance improvement is with the cache when using the SQL backend of the cache. So here we have an example. Here we have a query that returns like a hero and its friends. And the way the cache works is like to store the fresh data. It needs to first know if all these objects are already in the cache. And in V2, the way this worked was we would execute one SQL query for each object. And as you may guess, this is not very good for performance. In fact, you may recognize something that we call the n+1 problem that you sometimes find in other implementations of any SQL database. So what was implemented instead was a batching algorithm that allows to group as many as possible of these SQL lookups in as few as possible SQL queries. And yeah, that's an optimization that greatly improves performance. So that was the last big thing. Let's now look at more like smaller features and improvements.
So smaller is actually a bad name because it's actually what's visible for you, users. Like what we said earlier, like Kotlin rewrite, new Codegen. I mean, new Codegen is visible. Performance, this is really foundation work. Like, now I'm going to talk about a lot of like new nice to have stuff. And the first one is Apollo AST for abstract syntax tree. If you're not familiar with GraphQL, I can only recommend you go to the specification. Yeah, I know it's a weird recommendation. I wouldn't say that to, actually, yeah, I would say that to friends. The GraphQL specification is really nice. It's nicely written. And if you go to the end of it, you will see something like this, Appendix B, which contains the whole grammar summary for the language. So it tells you how to speak GraphQL. And what we call abstract syntax tree, actually, it's everything that defines in this section. So GraphQL, like any language, has verbs, token, nouns, pronouns, all this kind of stuff. And now, with Apollo Kotlin 3, you have a library called Apollo AST that takes your GraphQL document, parses it, and exposes a full Kotlin representation of it. If we take a simple example, with a query that is not taken from the Star Wars schema for once, but maybe from a schema like GitHub, like GitHub uses GraphQL for an example. A simple query like this, where you get a user, you can parse it with code like displayed on the right. So I'm not diving too much into the detail, but here it's an example how to get the query name, for an example for logging purposes. But this also unlocks a lot of new use cases. For an example, you could have an app, let's say an iOS app, because Apollo Kotlin also supports iOS, that talks to different servers. And depending the server you are talking to, you would like to send a slightly different query. So you could do this, for an example, by introducing your custom directive. So if you're not familiar with directives, this is, I like to think of it as the annotations for GraphQL, mainly because it starts with an arrobas and with an @. So anyways, you can define your @since, well, that's a typo, sorry about that, @since directive that you would use in your query, and that would allow you to remove the fields that are not understood by a given server at runtime. So talking about directive and annotation, so something else we realized while working in Kotlin is that GraphQL on one side and Kotlin on the other side, they have a lot of common. They have like all this typing information that is really similar. You have string, list, everything. One thing that's different though is nullability. GraphQL is nullable by default, Kotlin is non-nullable by default. And if you have been written like Kotlin code talking to a GraphQL endpoint, you always have to, in a lot of places, check for null fields, because in your UI, you don't want to display null in your UI, basically. So with Apollo Kotlin 3, you can now use @non-null in your queries. By using this directive, you can specify that the given field must be non-null in the generated model. So every time you use this, you are guaranteed that, for an example, email here will be non-null, and you don't have to do that check in your UI because it's done before. Moving forward, you can even define this at the schema level so that all the fields in all your queries are non-null. By using something that we call schema extension, you can put a file named extra.graphqls next to your schema in your repository. And in this extra.graphqls file, you can add extensions to your schema. Extensions that are only usable by the client, but still represent useful information. And by doing so, you are guaranteed that every email in all your generated code will be non-nullable. Talking about schema extension, I leave Benoit talk about type policy, which is another one.
Yeah, another one that will basically simplify your life as a developer. So related to the cache again, the way it works is you need to declare what field or fields to use as the key to be stored in the cache. And the way this worked in V2 is that there was a programmatic way, so you needed to implement some API. This is still there in V3, but now there's this simpler way and smoother way, which is declarative. Again, same principle. You can extend your schema and add this specific directive, as you can see here. So here we declare that for author, the key field is ID. For book is ISBN. And that's it. You don't have to do anything else. There's one bonus to do this, is that when you do this, these fields will always be automatically included in your selections from the Codegen, so you can't forget anymore, they will be there anyway. So that was it for the smaller things, and now let's look at what's coming next. And the first thing is, okay, so we made a library that's Kotlin first, and it's very good. I mean, it has an API that's good to use from Kotlin. That's good if you're an Android developer. What if you still want to do Java? For instance, if you're a backend developer, you may not work with Kotlin. We know that Kotlin has a good interoperability with Java in general, but as soon as you use coroutines, that's not really longer the case. Also, like if you have Kotlin extensions, like we do in Apollo Kotlin, sometimes they're a bit awkward to use from Java. And that's something we want to focus on. Here there's an issue tracking this. The idea is to make a different runtime which will have absolutely no coroutines in the API. So it will be more idiomatic to use from Java. And in fact, we already started this, so this is like a kind of a small announcement that you can already try this out, and it's all pre-alpha and not very stable, but you can already do some queries and mutations and a few other things. So yeah, don't hesitate to follow this ticket and give us feedback, because it's appreciated. What else is coming?
A lot more is coming. We want to do a lot more about caching, obviously. We want to add Windows support. I don't know if any of you needs Windows, but we need to add Windows support at some point. And we would love to improve the IntelliJ support for GraphQL. And my last point, your feature, like everything is open source. So if you have any idea or anything that you would like to see working in GraphQL, be it in Java or in Kotlin, please reach out. We are on GitHub. We are on the Kotlin Lang channel. We are also on Twitter. So do not hesitate to come around. We will also be in the conference. So please come say hi. And with this, I want to thank you all for attending. Thank you very much.
Thank you.
Do we have time for 2 questions, maybe? Like, we have 2 minutes left. Or 1 question. I have 1 question. How many of you use GraphQL? Oh, nice. 75%. How many of you use Apollo Kotlin or Apollo Android?
1%.
A bit less. All right, so if that's it, thank you all, and enjoy the conference.
Thank you.